All right, so now here we have the good stuff. Poisson distribution. And I think that's, what is that? This stuff? What do you call these? Oh, fish. In French, it's fish. There's a whole story why it's called Poisson. I don't want to talk about that. It's weird. All right, Poisson distribution. So with Poisson distribution, we are using our average to find a possibility of an outcome or a desired event. So if you see in this problem, a teacher kicks out on average 3 students per day. We'll say they just ask them to kindly step out and, take a breather and come on back. Yeah, we don't really ask them. I don't kick them out. Can't do that. No, nope, you don't do that. Nope. Sorry, that's just too negative. I won't do that. We don't kick anybody out. I'll never do that. Kick them out. Just ask them, take a breather outside and just collect your whatever. Anyways, yeah. So teacher, since it's not me, we'll just say this is Mr. Poisson. Mr. Poisson, on average, kicks out. Kindly asked an average of 3 students per day to just take a breather outside in the hallway for a second. Find the probability that Mr. Poisson asked exactly 2 students. So if Poisson is just like binomial, we'll say, I want to know the probability of exactly 2 students being asked to get some fresh air. I like that better. Get some fresh air. For example, I don't know, 2 students. It could be Bayman can go outside, and Bausto could go outside. Yeah, just 2 random names. I don't know. So let's say, okay, well, how do we find that probability? Well, remember I said this is all based upon averages. So here the average is 3. That's what it says. So we're gonna go to second distribute Poisson PDF because we want exact. Exact is PDF. So and look at that. That little symbol there, lambda. It means lambda. Lambda means the mean or the average. For us, it's 3 per day. Our desired value is exactly 2. And then we get our probability. Here we got 22.4%. Write that down. It goes 22.4%. All right. So remember, this lambda means the mean. Not like Mr. Poisson. He's mean, but this mean means average. Average. There you go. Okay. So at most 4 students. So the probability of 4 students or less. At most 4. So our desired event is at most 4. Less than or equal to 4. So let's find that. Well, like I said, this was PDF because it's exact. Since this is less than or equal to, this is CDF. CDF means this or less. This and everything before it. Cumulative. That's what the C stands for. Let's try that in the calculator. Oh, this is your favorite tool, I know. So, second, distribute to the bottom. Poisson CDF. And I'll do, okay, so it's 3 still the average. Desired is 4, less than or equal to 4. And then, boom, 81.5%. Remember what I said? You don't have to put in percent. I just like being fancy. So this is 81.5%. Now, at least 2 students, so it's at least 2 or more, at least 2 students were told, hey, I think you might need a few minutes in the hall. Just take a breather. So 2 or more at least. So again, like the binomial, we said, okay, the calculator can only do less than or equal to CDF. So we have to be fancy, creative. Creative, not fancy, creative. So this is what we want. Greater than or equal to 2. What do we not want? We can say, okay, well, the calculator can calculate what we don't want. So what we don't want is anything less than 2. We don't want this. Less than or equal to 1. So what we can do is say, okay, well, I'll find that and subtract that from 1 because probability always adds up to 1. So then this is what I don't want. This is what I do want. what's left over. So I'll say this is going to equal my probability of greater than or equal to 2. So we'll do that in the calculator. All right. So I'm going to do, first let's find, second, distribute Poisson CDF. Still average is 3. We want what we don't want, which is less than or equal to 1. And then we find that and we say, okay, that's what we don't want. We want everything else. So 1 minus that. And then boom, that's 80.1%. This will be 80.1%. Let's move this away. Equals 80.1%. All right. Now here this one says 2 or 3. Remember, there's that or word. Or means we're going to add these up. So 2. So probability of having a 2, or sorry, 2 students being asked, hey, take a breather out in the hall for a second. Or probability exactly 3. Hey, take a quick minute over there. So what we're going to do is we're going to actually find those and then add them because it's or. Do that in the calculator. Well, the first one already has 22.4%. We got that right here. Let's do 3. But I'll do them both just as a reminder. Demonstration. Okay. PDF. So 3 is the average. X value we're looking for is, first was 2. Exactly 2. Then we can go up here and say, okay, what about exactly 3? And we just add those two. So this plus this, and we get 44.8%. So 44.8%. Now here comes a problem you're definitely going to see. It's very, very common when we're talking about averages. They just want to test to see if you actually understand what average means. So here, this one says exactly 6 students are given a break. I'll say that, given a break in a week. Well, here our average is just per day. So if it's 3 students per day, on average, how many students are asked to take a breather in a week? Well, school only happens 5 days a week. So if it's 3 students per day, 5 school days in a week, we'll say, 5 school days times the average number per day. And we'll say, and a week on average is 15 students being asked to take a breather. So then this is our new average per week because it was 3 per day. So now we're going to do the same exact thing, except now our lambda is going to equal 15. Let's try that. It says exactly 6, so we're going to do Poisson PDF. Lambda is 15 now because it's per week. We said 6, paste, and then that's our probability. So it's going to be 0.0. That's how do you change that to a percent? 1, 2. So that's 0.484%. So when we do this, so this is exactly 6. We got 0.0048339. Multiply that by 100, we get 0.484%. Happy face.